Thank you, thank you. It's so good to be here. I love this office. It's cool. I run past here all the time. I had no idea this was here. It's like hidden. Hi, everyone. I'm Tejas. That's hard to pronounce, so think of contagious. That's how you say it. I'm not contagious, just for the record. But I've been building on the web for over 25 years at various places. Vercel, Spotify. Sorry about the issues with Spotify earlier. Zeta, a bunch of other companies. And I've been, for the past 3 or so years, deeply in AI. And so I'm very excited about this event to talk to you about AI. The title of the talk is called AI for Everyone, because it's relatively new. We've had the internet for like 30 plus years. We've had AI for like at least mass market AI, like ChatGPT, for like 2 years, right? It's very new. And where things are new, there's often confusion, there's often fear, there's often uncertainty, there's often doubt, there's often imposter syndrome. There's often people saying words that maybe they don't understand, but they're afraid to, so I'll give you an example. There were memes on the internet of some guy standing awkwardly and saying, I don't know what MCP is, and at this point I'm too afraid to ask. Does that, anyone resonate? No? Yeah, you'll hide. Yeah, he's like, I don't know if I want to admit that. But that's why this talk exists, okay? This talk starts at the top, surface level, and some of you may know these things, but we go pretty deep on what the problems are with AI, what the solutions are, agents, what even are agents. Google has published a lot of papers actually on agents, shout out Google. And MCP, Model Context Protocol, what is that? So we'll get you to 2025 in our time together, and then even maybe beyond, where is AI going, are large language models the future, and so on and so forth. I don't have any slides, because honestly this is a discussion, it's a dialogue, we can talk. I want it to be interactive, I don't want to just be some person talking at you, I want to talk with you, okay? Let's start at the beginning though, and talk about AI. If I ask you, so I speak at a lot of things. I've been speaking at conferences since 2012. Wow, do we need to like evacuate or something? Okay, anyway. Okay, cool, everybody stay calm. Okay. 2012, and in this time, I've spoken to a lot of people. Preparing this presentation, I speak to a lot of people, and I ask questions to prepare. And one of the questions is, do you feel like you could be an AI engineer? Do you identify with this term? Maybe you're a web developer, you're a Python developer, you're a machine learning engineer. And I ask you, show of hands, how many of you comfortably would be like, I could be an AI engineer? Yeah, that's like, okay, it's slowly people are getting brave. It's, I'd say that's what, 10, 12% of the room? That's why this talk exists, okay? At the end of this, I want you to confidently be like, I could do this. I could be an AI engineer. I want to eliminate some of that doubt in you, okay? That's the goal. So let's talk first about what an AI engineer is and what the discipline of AI engineering even is. Can I put the mic down? You still hear me, right? Whoa, that's so cool. Okay. Stay. So let's look at the foundational work defining the role of AI engineering. I have the privilege of being friends with the guy who defined this job title. Absolutely bananas. He was referenced earlier, Swix. You did. Swix, aka Sean Wang, wrote this article a long time ago, June of 2023, which is in AI years, that's very long. It's ancient. Put this in a museum, in the Computerspiele Museum. Anyway, so he drew this diagram, which has just been like the foundational work of what makes AI engineering. And it's this spectrum. On the very left, you've got machine learning research and research scientists. These are people who are doing the academic work. Machine learning engineering, which is training the models, doing the data science, doing the evaluations, doing lots of GPUs. Big dividing line down the middle. That's a dotted line, and it's important that it's dotted because the line can move, admittedly. And this is where we find the role of AI engineering, sitting in front of an API. And you use an API to solve a problem, and behind the API is where the machine learning sits, okay? And AI engineering as a discipline, as a specialization, composes into full stack engineering, which is not as specialized. Kind of like front-end engineering is a specialization, full stack engineering is the broad work. And so there's a note here, the API line is permeable, because you can kind of move a bit to the left and the right. It's not like a hard line. So I show this to a lot of people, and sometimes people get very upset. They're like, oh my God, you're devaluing machine learning work. It gets worse. Like people get even more upset when I simplify this even more, and I say things like, if all it takes to do AI engineering is speak to an API, then you can kind of do, like if you know JavaScript, you use the fetch function, and you send a prompt to like api.openai or api.gemini.google.com, and they send you a response, and you use that response to do what? To do engineering. What is engineering? Solving problems with the application of science, right? That's literally the definition of engineering. And so if you solve a problem with engineering and you use AI via an API, then you're an AI engineer. Now some of you are going to boo me out of the room. Like this happened. I mentioned it this way. If you can make a fetch request to a language model and get a response and solve a problem, you're an AI engineer. This actually happened. A bunch of folks in the room were like, that sucks. You're wrong. They didn't care about the code of conduct anymore. And I said, why? And they said, hey, I'm a machine learning engineer devaluing my work. And I said, no, I'm just making this more accessible to people. And they argued with me, but I tell you what, this is beyond argument. Do you know why? Because I'm not in any position to make a claim like this. This claim was not by me, and this is not my work. This is Sean's work. Go talk to him if you have a problem. But this exact diagram, this exact definition is backed by this dude, Andrej Karpathy. It says in numbers, there's probably going to be significantly more AI engineers than there are machine learning engineers or large language models engineers. He agrees with this and says this is true. One can be quite successful in this role without ever training anything. And a lot of people have this uncertainty and doubt. They say, I could never be an AI engineer because I don't train models. Well, guess what? You don't need to train models. And some of you may be thinking, okay, well, who's this guy, Andrej Karpathy, co-founder of OpenAI? The brains behind GPT-3 and GPT-2 and ChatGPT and all of it. Like he's like the GOAT on machine learning, data science, and AI. Okay, like if anyone is qualified to make this statement, it's Andrej, and this is what he says. So you have no argument against this. If you do, talk to Andrej, but he's, I think, way more skilled than the vast majority of us. And so, okay, now I think that should maybe already make AI engineering a little bit more accessible. If you know a programming language, you can make a network request. Cool. However, there are still some problems. And again, we're working with the definition that engineering is just the application of science and technology to solve problems. Engineering is heavily problem solving. And so, what are some problems then with AI? Because there's AI engineering as the application of machine learning, but there's also solving like actual problems with AI, right? If we think broadly, problems with AI, what do we think about? It's a dialogue. What do we think about?
Problems with AI?
Problems.
Yeah.
Hallucinations.
Great. Hallucinations. What's your name?
Ezra.
Ezra. It's
Yeah.
a great name. Thank you, Ezra. Hallucinations. Huge problem with like some search engines, I won't name them, but like when you search for like, how many cigarettes should a pregnant woman smoke
10.
per day?
10.
Yeah, exactly. They will hallucinate and say 3 to 4 per day or 10 per day or something like this. And it's a problem with AI because the training data sometimes has jokes and has a bunch of stuff and you don't know what you're going to get. Hallucination's a real problem. What else? What other problems can we get?
Privacy.
Privacy, exactly. But there's ways around this.
Copyright issues.
Copyright issues, yeah, exactly. Another problem is environmental impact. Absolutely. This guy knows all the problems. What? Your name was?
Ali.
Ellie? Ali.
Yeah.
Awesome. So many problems. Another, like a significant problem now that's going away, the Google team, the Gemini team, is doing really great work about this actually, is long context. Yeah, it's finite. And so you can have up to, what, 100 million tokens now in pro cases?
10 million.
10 million? Okay, that's still a lot. That's, if you consider one token being roughly an English word, that's an enormous amount of context. However, if you put that context in the context of an entire human lifespan, it still doesn't add up. So we still have like finite. The fact that context is finite is the problem, not the fact that it's small or big. And so if we can somehow unlock infinite or highly relevant context, great. Third problem is the models themselves are static. Yeah, they can't like get new knowledge. So when you finish training a model, you run some evals on it, you're like, okay, the output makes sense. Then you host it. I've done all this, by the way, the whole end-to-end pipeline. You host it on a very powerful machine with a cluster of GPUs, and you can perform inference. You can ask questions, get answers. But if you ask a model that was finished being trained in like 2023, if you ask a question about 2025, it can't answer you because it's not in the training data. So those are, I would call these honestly the big three problems. Yeah, hallucinations, great one. Ezra, thank you. Bias, yeah. That's more a machine learning problem, to be fair. But hallucinations, finite context, again, not long or short context, just the fact that it's finite, and the static training data. And so how might we solve all of these? We're solving problems. Yes, how might?
Where would you put ethical worries that are?
That's a good question.
Under there or somewhere else?
I would put it under there, but this falls under maybe a sub-classification of non-technical. It's personal, it's social, cultural. Yeah. So in terms of technical problems, I'd love to zero in on these three. Finite context, hallucinations, and static training data. How might we solve these? There's really one silver bullet answer to solve all of these. Can anyone name it for me? Yes?
Keeping it alive all the time, like we go to the speed with up-to-date data.
That's very expensive to train. But you're close, you're close. The solution is a technique, a very popular technique called RAG. Who said that? Of course it's Ali. Ali knows, Ali's like an AI model right here. RAG, anyone who's familiar with RAG? Who feels so confident with RAG you could explain it up here? All the hands. Okay, let's make this very simple. Again, I don't have slides, but here. So this is a whiteboard, and RAG, let's do it like this, RAG, and let's zoom in. This tool is TL Draw, by the way. It's a wonderful, wonderful tool. RAG stands for Retrieval Augmented Generation, okay? This is kind of a problem in machine learning and AI where there's like these big words that, did I mute? These big words that sound scary, but they're very easy. In machine learning, there's another term called stochastic gradient descent. Wow. It just means like try stuff randomly and make less mistakes over time. Anyway, it's like doctors, you know, like what is it? Like pulmonary embolism. You know, it just means you have a blood clot in your lungs. So like speak English, okay? Or speak everyday language. And so retrieval augmented generation really just means you get some authoritative data, you retrieve, you're with me, you retrieve, and you use that to augment or change the generated output from the model. You retrieve and you use it somehow to change the answer. How do you change the answer? You change the question. Whoa, philosophical. So prompt engineering is how you perform RAG. So let's use a great example of exchange rate. I'm Indian, okay? I don't work in tech support. Can I say that? Is that violating code of conduct? Anyway, no, so people think that sometimes. Anyway, so I want to know, how do I convert 118 Indian rupees into euros? And I go ask my LLM, my language model, and usually it's gonna say, I don't know. I don't have today's exchange rate. This is where you need RAG. You need retrieval augmented generation. So how do you do RAG here? Again, the model stays the same. RAG as a technique does not affect the model at all. Instead, it just changes the output by introducing modern real-time, like today's context. So how do you do it? You fetch from some API, from the internet, the exchange rate in question. You put that in your prompt. So before your question, you just prepend your prompt. Hey, ChatGPT, the exchange rate today for Indian rupees to euros is like 1.89. I wish it was. It's 10.89. Now do the conversion. So you give the context in your prompt. Does that make sense? That's literally RAG. You just inject like modern and so let's look at a little demo of how we can do this. I work at a company. We make a tool that makes it very easy to build like AI APIs and like diagram them. This is not a product pitch. Don't worry. I don't care if you use this or not. But I just want to show you RAG here. So this is the diagram. I'm just going to delete all of this, and we're going to just create a very quick AI application pipeline. It all starts with the chat input, okay? And what you have from the chat input is a prompt. You can actually, let's just do chat input, chat output. Let's expand. Can I expand you? Can I somehow, oh there, this one, expand. And then we'll have a language model in between. So let's get, we have Google Jet. I don't have an API key for it. I would use Gemini, but I don't have an API key. I'm sorry. I do have an OpenAI API key handy. should have prepared with.
AI.def and you can generate one.
Are you serious? Let's just do it in real time. Why not? It's the last talk too, so I don't even have a time limit. I'm joking. So let's get an API key. Whoa, I consent. I don't know what I'm consenting to, but this is cool. Okay, so where's my API key? This is awesome. Sure,
Just
this one.
Whatever. And
Okay, and we'll get an API. This is the first onboarding for me as a developer. Thank you, man. So this is my API key. Hey, fantastic. Give it up for Google, everybody. That was so smooth. All right, let's.
We all get free API keys?
Yeah, that's what he said. That's what he said in his talk. Go right now, brother. Sign up. All right, so Google Generative AI. And so where's the API? I'll paste the API key right here. And now I pass the input here. I get the message to the output. And in theory, this is all we need. So I'm going to quickly go to the playground and just type hi. And there we go. Hi there. How can I help? This is great. So now I might ask, like, what's the latest news in 17 April? I'm not sure I want to know, honestly, but can it perform RAG, or is it just the model? Okay, as an AI, this is 9 out of 10 times is what you get. So you might be thinking, what does RAG look like? Well, I'll tell you what, ChatGPT performs RAG.
Yeah.
Let's take the same prompt, and go to ChatGPT, and we'll hide my history, and we'll, what's the latest news in April 17th, 2025? And so searching the web, you see that? That's called RAG, everybody. And so it does RAG, and then it gives you this, whoa. Okay, that's, I don't know, whatever. So how might we perform RAG ourselves as developers? That's the question. Well, we could actually do that right here. There's a URL component. This will go get data from some URL. So let's go find like a news website. Wikipedia, yeah? Wikipedia Today News. I think Wikipedia has, yeah, current events. Okay, let's copy this. I'm not sure I'm going to like the news today, now that I think about it, but we'll get this. And we need to now engineer a prompt with RAG. So we'll add a layer here between the input. We'll call it prompt. And so now we write this is prompt engineering, and this is a RAG prompt. Given this context, I will create a variable context. Answer the question. These are two variables, okay? This is how you perform RAG. And so now, question goes here, context comes from the URL. It's important that the website is readable without JavaScript. This is important. If your website requires JavaScript, then good luck. And now we take the prompt and we pass it to the input. And now everything should follow. So let's go back to that playground. We'll start a new chat. What's the latest news on April 17th, 2025? And so it's going to use all of this context gathering tools and give the prompt to Gemini. There we go. Look at, wow, amazing. And so April 17th, 2025, this is actual reality in the world today. It's stuff that's happening. So we went for, let's go. So here, as an AI, I don't have access. We immediately fix the problem by, hey, as an AI, I do have access. Yeah, that's solving one of the biggest problems. And so you might be thinking, okay, well, how can I, that prevents hallucinations pretty well. So that fixes the static knowledge, right? That can fix the hallucinations, because you get, like, you give the answer basically. How can you hallucinate an answer when you're giving it the answer, yeah? But there's still the problem of context length. It's not infinite. You can go very far with this. You could get the entire, I think at this point in time, it's 25 megabytes. I'm not sure. You could get the entire HTML specification, massive document, and put it in context. And you could get, what was that long book you said? You said there was some super long book that would fit in. Anyway, Harry Potter. You could get Harry Potter. Yeah, yeah. You could do RAG with Harry Potter. Why does Voldemort not have a nose? I don't actually know the answer to that, but maybe the LLM will. So we solve all these problems with RAG. Is that clear? Great. Okay. I have like 20 minutes or so. Yeah. So I'm tempted to really not respect the timeline at all because it's the last talk, but I will. That's a very important technique, RAG. We could talk a little bit more about how to work in an environment with limited context. And the answer to this is something called vector search. I won't go deep here because honestly, time, I do want to respect your time. If I didn't, I would give you a whole thing on embeddings and vectors and so on. But vector search essentially is just similarity search. So you break a long document, which is like 200 billion tokens. You break this into a few chunks of like 200 or 1,000 characters, and you assign them a similarity value. And then when the user sends a query, you check, okay, what is the closest text that is similar to the user's query? And you include only those similar chunks in your RAG prompt, okay? That's how you get over the finite context problem, by adding similar context to the user's question. Is that clear? There's another level of this, which includes keyword matching, because with RAG and vector search, you match on similarity. So for example, Italian food and pizza would match, but you don't match on keyword. Pizza and pizza only. And so usually you can have some issues with that, and the solution to that is something called hybrid matching, which uses usually the BM25, best match 25 keyword algorithm plus similarity search. Those are, I think, maybe too deep details. We won't go in there because we have a lot of ground to cover. This is RAG. This is technique number 1 to solve the biggest problems, the biggest technical problems, not counting ethics and environmental impact, the biggest technical problems with Gen AI. Thank you for yawning. Joking. So the next topic, so RAG was cool, RAG is cool, RAG is very useful, but as time progresses, what else comes into vogue in the AI world? MC, that's a bit too far, yeah, but it's close. Before that, we have agents. Agents is the term. People started this year saying things like 2025 is the year of agents. Anyone heard this phrase? Yeah, 2025 is the year of agents. And sometimes I just feel like responding to these people going like, who told you to start conversations this way? You know, how about Happy New Year? You know, like at midnight in 2025, it's the year of agents. I was like, Happy New Year? No. So agents, what is agents? What are agents? And for this, I'm actually going to reference a great Google paper. I will say Google is like doing a lot. Why is that funny, man? Google's doing a lot. You know, they're moving so fast and they're doing like 1 billion different things, and this Gemini, this and that, and like, wow, it's just like startup mode. But as part of a lot, they publish a lot of research, and this is honestly where I find the most value. They published 2 papers recently on agents, one in I think it was September of 2024, and a more recent one, February 2025. We look at the 2024 paper because it's more foundational. It's like, what actually is an agent? Let's take a look at this. It's this one, PPC Land. This is also available everywhere, but this is a paper by Google. The Google folks are so happy I'm sharing their research. Anyone seen this paper before? Okay, like, yeah, 1% of the room maybe. This paper was by these wonderful, brilliant people from September of 2024, I was right. And it's actually not a long paper, it's like 42 pages, but this is the working definition of an agent, according to the Google paper, which I think is great. The combination of reasoning, logic, and access to external information that are all connected to a generative AI model invokes the concept of an agent. So what is an agent? It's a concept that is characterized by reasoning, logic, and access to external and internal, honestly, information. They have a really great diagram in this paper that I think sums it up very well. So a user sends a query to an agent, which is a runtime. An agent, I think it's a great example. What is a runtime? A runtime is an environment in which code executes that the runtime provides context. Runtime is really a context provider. If you think about the JavaScript programming language, the browser is a runtime. It gives you the window object. Node.js is another runtime. It gives you system level access. Yeah? So a runtime gives context. That's a wonderful analogy. And so a user sends a query to the agent, and the agent composes 3 components. An orchestration layer. Think of this as your application. Your application ties everything together. It does things like reasoning, thinking, memory. You would store your memory in some type of vector database or similar. You need, of course, a language model like Gemini, the gold standard. And you need tools. You need access to external tools. This is an agent. We already know models because we talked about them. Let's spend some time talking about tools, and then we'll talk about the orchestration layer to fully understand agents. Tools. What are tools? In fact, let's go back one level. What's an agent? Semantically, an agent is an entity that can exercise agency. Agency, yeah? An entity that can exercise agency. So by this definition, I am an agent, you are an agent, we're all agents. We're all agents of the things we choose to do. We use our agency when we choose to come to a meetup, when we choose to have dinner, when we choose what to have for dinner. Agency. And that's what we want to replicate with AI. It's artificial agency. As part of our agency, if you ask me to multiply 18 prime numbers, I'm going to look at you and say, what is even a prime number? I can't even multiply. I'm not that smart with numbers, okay? But I have agency to choose the right tool for the job. Does that make sense? So I know, okay, calculate. I'm going to grab a calculator. I know this. I know the end of my knowledge and the beginning of my tools. Does that make sense? So with my agency, I'm going to grab the right tool, the calculator, and then what's going to happen? Think of the calculator as a function in code. Functions have what? They have inputs and outputs. They have inputs and they return you a value. I'm still using my agency to generate the inputs to the function. Does that make sense? So the calculator in itself is just a calculator, but I am using my agency, my language model, to generate the numbers, the prime numbers, and the operation. And then the tool gives me a return. Does that make sense? This is literally the same thing modeled in code, okay? So tools are exactly what they sound like, except in code, they're just functions. They're functions that take inputs. The input values are generated by a language model, and they return something back to the green orchestration layer to either then send to the language model again or to give to the user. The orchestration layer can decide. Is that clear? I think that's way too much theory. Let's make it super practical with LangFlow. Just full disclosure, I built this langflow.new. That's where I'm going for all this. I built this myself just because I explain this stuff a lot and it just makes it very easy. So this by default is an agent right here. Add your OpenAI API key over here. Let's fix this and let's, there, that's better. And you get dropped immediately into an agent, and you can watch a tutorial on anyway. But the agent is you can choose a provider. I think let's use Google. An agent fundamentally, this is the orchestration layer. If that wasn't, this is the thing that ties the language model and the tools together. Okay, so we have this agent. I hope the API key is still in my clip. It's not. It's okay. I can go copy it from my history probably. It's this one. Yeah, it's probably this one. Let's try it. Okay, so it's my API key. And so what do we have here? Well, this agent has two tools. You can see the tools by this green thing. We've got a URL tool, so this agent can browse the internet. And we have a calculator tool, because language models typically are very difficult, very bad at math. Like the new Gemini models are great, the reasoning ones, but 3.9, 3.11, which is bigger, it's 3.11. That's what it says, it's not. And so we use a calculator just for some extra safety, okay? And then finally you have your classic chat input, chat output. So this is our agent. Our agent receives an input, has some tools, and can give you an output. And again, it can use the tools. So let's now use the agent, hoping my API key is correct. Do I still have it here? Oh, awesome. And so we'll just paste my API key, and we'll use the agent. So I'll go to the playground, and let's use that example from earlier. For example, what is this much, actually maybe that's too much, this many euros in Indian rupees, yeah? And I will send this to Gemini. And it's going to, I'm sorry, I can't, wow, man. Let's choose a more capable model. How about that? Let's, 2.5 Pro, fantastic. And this is also kind of valuable with LangFlow. I can just go and switch. So let's copy this prompt and try not all models can use tools. That's the error we saw there. So let's do this. And so it's getting the input, and it just disappeared. Ooh, resource exhaust. You're rate limiting me, bro? Okay.
Sorry.
Man, I wish that worked. Okay, so let's just use OpenAI. I'm so sorry. I swear I didn't want to do this. And I'll paste my API key here. That rate limit was very low. Can I pay to get more? Anyway, okay, so I will paste this. And so the cool thing is you can switch between models as much as you want. So we get an input, it's accessing the URL thing, and you can actually see what's happening. So it used its agency, used the URL tool, went to api.exchangerate API for euro, whoa, and it got back a bunch of JSON, and then it completed the task. The current exchange rate for 1 euro is 97.32 Indian rupees, therefore to convert this, it's that. Look at that, incredible. So that's an agent. You say, here's some tools, and it will use them with agency. It used the URL tool, and I want to exactly emphasize that it generated the inputs, yeah? It said, hey, URL tool, go here. I didn't write this. Also, the numbers for the calculation, all of that was generated. Okay, well, I gave the numbers in my prompt, but that's what an agent can do. Does that make sense? Agents are, was someone say something? No, okay, agents are extremely powerful because the tools scale very well. You can have as many tools as you want. In fact, if I click on this green thing, all of these are tools, yeah? There's all kinds of different tools. So you can add as many tools as you want, and agents can do stuff. So what we just saw with the exchange rate was RAG. But this is an example of agentic RAG, because I didn't retrieve anything and put it in my prompt. The agent did all the work. And this is RAG v2, and this is the new, better way to do RAG, okay? Now that we have a working understanding of agents, we'll wrap up. I'm almost finished. I do want you to get some question time. We have to, the next oh shit, I'm not on the camera. Wait, let's go back. The next, oh, the camera can't move. That's so sad. The next evolution of AI applications is MCP, as Ezra mentioned. MCP it stands for Model Context Protocol. Can I find the blog post? Yeah, here, introducing the Model Context Protocol. This is foundational work by Anthropic. David at Anthropic created this, which is, it's a protocol. Fundamentally, it's a client-server protocol, exactly like what you know to be client-server protocols. There's a server. Like if we go to a website, there's a web server that's serving you as the client. Yeah, it just sends you stuff, and you send the web server back stuff. When you submit a form, you send, it's that. It's a bidirectional protocol. Nothing special, except very special, because it's a standard way to share tools and context and prompts with agents. So it's just a standard way. So the diagram for MCP, or Model Context Protocol, would look like this. We're just gonna draw this here because I can't think of where I can find one. But it's like this. This is your app, and inside your app, you have a language model. Ooh, that grew. But you have a language model. This is sitting inside. Let's maybe make this bigger. You have a language model inside your app, and you have a MCP server. So this is a server, it sits somewhere, you don't know where, you don't care. And your application says, hey server, what capabilities do you give me? And the server says, I have all these tools. And then the application coordinates that with the LLM connection. Okay, so it's an application to server, it's not an LLM to server. Right? That's what I'm trying to say. Let's look at a demo of this in the wild. I think that's really the best way to show it to you in the time we have. So how might we do that? We need a server and a client. There's two kinds of, there's many MCP clients, but the two most popular in the world are Claude Desktop and Cursor, the code editor. Does Google have a MCP client yet? No? Okay, soon.
It's coming.
Hey, it's coming, let's go. So let's
say Gemini Code Assistant on MCP.
Gemini Code Assistant is an MCP client? That's cool. So I work at a company called DataStax. We make a database. This is our database right here. And usually when you work with databases, you talk to them over APIs, like HTTP, you make requests. But I thought, what if we had an MCP server? And so I made one. And I'd love to show you, just to blow your mind a little bit about what MCPs can do. So we'll actually just in real time go follow the README of this. GitHub.com, this is all open source. This is our MCP server, and let's open an MCP client. So Claude Desktop is an MCP client. Hello, Claude. Wow, you were going to make me sign in? Okay. Continue with Google. I got logged out, I guess. Wow, I have to click this twice. Isn't this cool? We sign in with Google. You see, y'all dominate everything. Amazing. So I'm back. Hello, Claude. Do you read me? Great. Okay, so this is Claude Desktop. And what I'm going to do is add my AstraDB MCP server to this. Here's how MCP servers run locally on device. So they're not going to leak stuff. They will run remotely as well. You need to be sensitive about security, but we'll run this one locally on the device, okay? So here's how you do it. This is Claude Desktop. You copy this JSON file and paste it. So you go to Settings, Developer, Edit Config. It's literally a JSON file. Like, they could do a little bit better, I think, with the UX of this. Of course, I have to update Visual Studio Code right now. Okay, so thanks. And so you just paste it right there. And now, you give it some credentials through environment variables. That's usually how you do it. So let's go there and let's just generate some credentials. I have an API endpoint, and we'll just do this. And I will generate a token. Hi, hate, sure. I'll generate a token, and we'll paste this token right here. That's it. So now if I quit, let's just quit Claude Desktop and restart it. It will come alive with MCP superpowers. So as you can see, nothing has, okay, there we go. So 16 MCP tools available. I just became aware of that. Because as soon as I opened this app, it sent a message to the server that I made, which is running on localhost. And it said, hey, what tools do you have? 16 tools. Okay, cool. I got all these tools. I can do database stuff now. And so there's really, think of it as an HTTP server with 2 endpoints. What tools do you have? And use the tool. Okay? So we already called what tools do you have. Let's use the tool. Let's say I am starting a business for financial advisors, like a portal, and they service clients. Build my DB. Enter. This is the future of like scaffolding